Hello. There was some request to understand how to carry out the Boyer-Moore algorithm. So let's take a look at it now. So Boyer-Moore is a very interesting case whereby, of course, throughout our entire journey of string matching, we talked first about brute force algorithm, where in the brute force algorithm, we have n. If let's say I'm looking for a needle in the haystack, and my needle has length of n, my haystack has length n. The brute force algorithm actually gives us n times n kind of yeah. So we first started off with that, and then thereafter we went on to the next one, which is the KMP, the KMP algorithm. And of course, in the KMP algorithm, the hardest thing is getting out with the DFA matrix. Once you can come out with the DFA matrix, you should be fine for that. And now recall in the previous recording, we typically do that through the x variable. Here we always do that through the x variable. If you use the x variable, we keep it in check. Your DFA matrix should be able to be created pretty easily. In the DFA algorithm, the big O is big O. Okay. So we call this more of a linear algorithm. So the KMP algorithm is in fact a linear algorithm. The next one that we went on is the Boyer-Moore algorithm. In the Boyer-Moore algorithm, we are actually going down to a sublinear. It is in a way still bounded by ON, but in the average case, we are actually going to go lower than n. So it is still bounded by ON, but in the average case, it is going to be less than n. Okay, so how does the Boyer-Moore algorithm work? Okay, let's look at an example. Okay, in the Boyer-Moore algorithm, you are going to be matching two, as what we have seen so far, the needle and the haystack. So let's say that I'm going to be matching certain numbers. I'm going to be matching T, L, E, D, E, and then let's say that the one I want to match is so far going to be let's say a good example, E, 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 E. So this is my haystack, and this is my needle. So what we have seen so far is that we are matching the needle and the haystack. Let me change some this. Not the best. Let me remove this E and replace this with an F. So what we will do is we will match from the right side, because we always match starting from the right side. And this is a match. This is a match. So this is not a match. Okay, when we don't hit a match, there can, in a way, only be two scenarios that can occur. What are the two scenarios? Okay, in scenario 1, the character is in the middle. Oh, not in the middle. Yeah, which means that my thing is not very correct. No, not correct. Not the best example for this. Okay, I apologize. Okay, so let's look at the first scenario whereby the mismatched character is not in the middle. If the mismatched character is not in the middle, what we do is we would know that this character is not in my entire needle, and so I can shift my entire needle forward, and it will become TLZ B something E E B B. Okay, why I can do that is because I know that no matter how I match this character being not in my needle, that there is no chance that my needle will be able to match that character. Hence, I can shift it all the way in front beyond the character that is not matched. So in the example that I gave to my class, which they say is very old school, I gave them the example that if let's say I'm playing a game, and in order to come out with some special combo, I need to press this sequence of buttons. So I need to press a sequence of buttons for my character to execute a very unique combo pattern, for example. And let's say if my sequence of key presses come out with, let's say, something like this, and something like this, something else. I know that my combo pattern can't happen anywhere here near here, because there is a button here that's not of my combo pattern. And so that means that I can begin looking for the combo pattern from here onwards. So this is exactly what we are doing, whereby we have found a character that is not in my needle, and so I can shift the entire search space to one character beyond T. In your notes, this is slide 46. Okay, so this is scenario 1. Let's now look at scenario 2. So I used the example earlier. So we have scenario 1 whereby how to say, the character is not in the middle. So what is the other possible scenario? The other possible scenario is when my character is in the middle. So there's only these two possibilities that can occur, correct? So scenario 2, this character in middle. Okay, so that's scenario 2. So let us use back the example that I was using earlier. E, F, dot, 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 E, E, B, B, X. Okay. Now, again, we check from the right side. Here, there is a match. Here, there is a match. And it is at this point that we find the mismatch. Okay. What happens when we find the mismatch? We would try to match it with the, remember, the rightmost character. This is important. So in this case, the mismatch character is E. And so we'll try to match it with the rightmost E character, which is. And so the next step that we need to check will be T, L, E, B, F, E, 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 F, something here. So we check with the rightmost. This is the rightmost E character. We align the mismatch with the rightmost E character. Okay, let's try to do another example based on this scenario. Let's say now I have E, T, L. I'm not extremely creative with my examples, and so no choice, bear with it. So anyway, F, D, E. Let's see, I have L, E, E. So in this level, okay, so the top is the haystack, the bottom is the middle. So in this example, we match this, and there's a mismatch over here. What do you think is going to happen next? We're going to match this with the rightmost character E. And the rightmost character E is here. And so this will become E, T, L, E, B, F. And this will become E, E, L, B, B, F. So this is scenario 2, where the character is in the middle. So there is an heuristic that comes out in our this is slide number 47. Okay, but let's now look at one example where this scenario 2 is not effective. Okay, let's TLZBF. Let me use back the example again. TLZBF and EEBBF, E, 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 E. Okay, let's use E here, and instead of Z, we have E. Okay, now let's look at this example. We have match E, fine. We have match B, fine. Here there is a mismatch. So if there's a mismatch, we check if the character is in my middle or not. And yes, it is in my middle. So in the case of scenario 2, what we do is we shift it to the rightmost character in the middle. But if we shift it to the rightmost character, what we are going to get is going to be the following: T, L, E, 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 E. What's the rightmost character of E? Is this E over here. So we end up with the unfortunate situation that we are shifting back. And this is the situation that we want to avoid. So in this case, scenario 2 by itself is not sufficient. Hence, we add scenario 3, whereby character is in middle, but heuristics fail, by which we increase by 1 step. Okay, this is in slide number 49. In this scenario, what we do is we just increase it by 1 step, which will give T, L, E, B, E, 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 E. We shift this by 1 step. So this is it's called the third scenario. Okay. Maybe as a recap, these scenarios are used in this course, and especially scenario 3, somewhat simplified. If you were to look at other textbooks or other videos, there will be more sophisticated ways of doing scenario 3. But in our course, we have chosen to do it in this manner. I think it's easy to understand. You just need to implement 1 if you see the character in or middle, and it works as well. So as a recap, for the Boyer-Moore algorithm, you have 3 scenarios. The first scenario is when my character is not in the middle. Okay. And when that happens, you select all the way after the mismatched character. In the second scenario, your character is in the middle, and you would try to go to the rightmost character in the middle, or rather align the mismatched character to the rightmost character in the middle. However, having said that, if it doesn't work, if you are moving your needle back, what you do is you will have fallen under scenario 3, whereby your character is in the middle, but the heuristics is not helping. And so in that situation, you just need to increment your needle by 1. And that will be able to resolve that situation. Okay. So this is the Boyer-Moore algorithm. I hope everybody, I hope you are clearer after watching this video. Thank you.